Hi everyone, I'm Dr. N. Today, let's talk about how to use Spark NLP for text classification. Spark NLP is an open source text processing library for advanced natural language processing for the Python, Java, and Scala programming languages. The Spark NLP library is built on top of Apache Spark and a Spark machine learning library. Spark NLP is currently one of the most widely used NLP libraries in the enterprise. In this tutorial, we are going to learn how to use Spark NLP for text pre-processing and build machine learning models to classify text into different categories. First, we need to install the PySpark as well as the Spark NLP into Google Colab. Then you need to import other modules. After that, optionally, you can use the code below to wrap strings when printing in Colab. And then remember to mount your Google Drive to Google Colab so that you can use the dataset stored in your Google Colab. Today in this tutorial, we are going to use the BBC News summary dataset. You can download the dataset from Kaggle. The link is provided here. The BBC News summary dataset consists of 2,225 documents from the BBC News website corresponding to stories in 5 topical areas from 2004 to 2005. There are 5 class labels, including business, entertainment, politics, sport, and technology. Here shows the dataset structure. We have news articles from the 5 different categories, and each article is a separate txt file, and they are named 001, txt 002, etc. And also, we have a separate folder that include the summaries of those news articles. And again, there are 5 categories: business, entertainment, politics, sport, and technology summary articles. And each article is also a txt file. In this tutorial, we are going to use the summary documents. First, you want to start a Spark NLP session using the Spark NLP.start method. After you start the Spark NLP session, you can start to read in the txt files. In Spark NLP, the whole text file method will return an error when it finds a nested folder. Because here, in the folder of the BBC News article, we have 2 subfolders: news articles and summaries. And within the folder of summaries, we also have 5 subfolders. And each folder is named by its topical area. And in each subfolder, it contains a number of txt files, basically summary articles. So therefore, we need to create a file path list by traversing all nested folders and pass all file names with comma separator in order to create a single RDD file that the Spark NLP is going to work with. So therefore, we first specify the root directory, in this case, the summaries folder of the BBC News summary. And then we use list comprehension to traverse and get a list of all file names within the summary subfolder and all the subfolders under the summary folder. Then we can take a look of the number of files. We have 2,225 files. And then we also listed the first file, path, and name. Now you can use the Spark NLP to import all txt files in the list. Here we use the join command to use the comma to separate all the file names. After we create the RDD file, we name it text, and then we can create a schema for the imported files. Here in the schema, we have two fields. The first field by default is the file name, and it is a string type. And the second field is text, basically the article summaries, and it's also a string type. So here we create a schema for the imported files, and then we are ready to create a Spark NLP data frame. We use the function create data frame and then provide the RDD file text and also the corresponding schema that we built. And then we can use the show command to take a look of the first 20 observations in the RDD file. And as you can see, we have two columns. The first column contains the file names, and the second column contains the article summaries. To produce better presentation in the data frame format, we can convert the Spark NLP data frame to Pandas data frame that most of us are familiar with. So here, we limit the conversion to the very first 5 observations in the RDD file and use the toPandas command to do the conversion. As you can see, this is in the format of the Pandas data frame. And now we want to create a new column that stores the article topics for the text summaries. Here, for the text RDD file, we use the with column function to create a new column, and we'll call this new column topic. And we'll use the split function to split the file name with the backslash, and we are only going to get use the get item command, the index 8 after the splition. And the index 8 corresponds to the topical area. As you can see, after using the with column command, we have created a new column called topic, and that column contains the topical area, basically the 5 topics pertaining to the article summaries. And then we can also take a look at the number of documents pertaining to each label. We can use the group by command, and we group the article by topic, and then we count the number of article summaries within each topic. And then after conversion to the Pandas data frame, we can use the Pandas plot function to plot a bar chart. And as you can see, we have a total of 5 different topics: politics, entertainment, business, sport, and technology. And their number of article summaries within each topic differ from less than 400 to about 500. We can also take a look at the schema of the Spark NLP data frame using the function print schema. And as we can see, there are now 3 columns: file name, text, and topic. Now let's random split the Spark NLP data frame into train and test sets. Using the function random split, we are going to split 80% of the data to the train set and another 20% to the test set. Now we can start building the pipeline for text pre-processing. First, we want to define the assembler. And to create a document assembler, it asks for the input column and output column. Here we specify the input column as text, and we name the output column document. And we can then use the transform function to do the transformation. After that, we convert it to a pandas data frame. And as you can see, we have added an additional column called document. And the document basically is the processed and transformed observation of the corresponding text using the document assembler. And the next step is to define the sentence detector. The sentence detector is going to do further pre-processing on the document so that for each observation in the document, it's going to separate the sentences from the text file. And then we set the input column to be document, and we name the new output column as sentences. Again, we can do the transformation, and we can take a look at the sentences. After we convert the document into separate sentences, we are ready to do the tokenization. Here, we define the word tokenizer, and the input column is the sentences, and we name the new output column as tokens. After we have tokenized the sentences, we can do further text pre-processing. For example, we can do lemmatization. And here, first, we import a lemmatizer model. It is a pre-trained model. And then the input column would be the tokens, and we name the new output column as lemma. After lemmatization, we can use the normalizer in the Spark NLP. The normalizer can normalize the text, for example, removing the special symbols, for example, HTML and other special symbols from the text, and also convert all the text to lowercase. So here we set the input column as lemma and the output column as normalized. And then we can also choose to set all the text into lowercase. And after that, we should define the finisher. And finisher is to convert the text or string file into arrays that can be utilized in machine learning models. Here, the input columns are normalized, and we name the output column also as normalized, so that the array is going to replace the text, the corresponding text. And after that, we can define the stop word remover. First, we can bring the stop words, commonly used stop words from an English dictionary. And as you can see, we have a number of stop words here. And then we can define the stop words remover. The input column would be normalized, and the output column would be filters, meaning after removing the stop words. And then we can define the count vectorizer. And we use the count vectorizer function to do so. The input column would be filtered, and the output column is TF, denoting term frequency. You can also optionally set the minimum frequency that you want to create a term frequency. And after you create the term frequency, you can further define the TF-IDF, standing for term frequency inverse document frequency. And we use the IDF function to do that. The input column is TF, and the output column, we name it TF-IDF. Again, you can optionally specify the minimum document frequency. Since we have defined all the individual text processing functions, now we can link them together and put them in a sequential order using the pipeline command. In the pipeline command, you specify all the procedures, the functions that we've specified in order. So we put assembler first, and then after document assembler, we specify the sentence detector, and then we tokenize the text, and then we lemmatize the text, and then normalize the text, and then finish converting the text into arrays, and then we remove the stop words, and then we do counter vectorization, creating term frequency, and finally we compute the TF-IDF, term frequency inverse document frequency. Then before we can feed the data to the model, there's still one additional task you need to do. That is, you need to convert the labels, which is still in the string format, into indices, integers. So here we define a function to convert labels to indices and use it to feed the data. We use the string indexer function. The input column is the topic because we have 5 topics to classify. And the output column by default is called label. And then we can use the string indexer to feed the text. After that, you can take a look of the indexed labels. Not surprisingly, we have a total of 5 labels for sport, business, politics, tech, and entertainment. And after that, you can also define a function to convert the predicted indices back to labels for interpretation purpose. So here we use the index to string command. The input column is the prediction. Basically, that is what is predicted by your machine learning model. And then we name the output column as predicted label. And then you provide the labels, basically a list of the 5 topics from the label indexer. And now we are ready to define a model. There are many machine learning models that you can try. So here, as a first example, we use the naive Bayes model. You need to provide where the machine learning model is going to use the features. And here, the features are in the column called TF-IDF. So we are going to use the TF-IDF as the features to feed into the machine learning model. And then you can define the overall pipeline. The overall pipeline contains the text processing pipeline we've defined previously. And then in addition, we have the label indexer, and then the naive Bayes model. And after that, we do the prediction using the prediction de-indexer. And then we are ready to train the model. Training the model in Spark NLP is very simple. We just use the pipeline fit and then providing the train set. After model is trained, you can use the model to do prediction by using the transform command. Here, we first predict the labels on the train set, and then also we predict labels on the test set. Then we choose to use the F1 score to evaluate the performance of the model. And you can initiate the F1 score using multi-class classification evaluator. You specify F1 as the metric name. First, let's report the F1 score on the train set using the evaluate command. And we see that the F1 score on the train set is very high, is 99.1%. And then let's report the F1 score on the test set. The F1 score on the test set is also pretty high at 92.7%, but it is lower than the F1 score on the train set, possibly suggesting overfitting. And you've learned how to use the Spark NLP to do a classification, task classification task. And now let's define a function to try out different ML models. So here we define a function, and using the function, we can first fit a logistic regression. And the logistic regression has a F1 score on the train set of 100%. Whereas the logistic regression produces an F1 score on the test set of 92.2%. And finally, let's try a random forest classifier. Surprisingly, the random forest classifier did not perform very well. It has a F1 score on the train set of only 79.4%, and the F1 score on the test set is only 72.1%. This concludes our introduction to the Spark NLP to do machine learning task classification problems. I'll see you next time.